right geometry. Here we are with our special right triangles. We are going to review these special right triangles for your virtual day today. Or I guess you might be watching this at school, depending on what day it is. All right, so we had two types of special right triangles. You have your 45, 45, 90 triangle, and then more 30, 60, 90 triangle. So 45, 45, 90 triangle, each of these special right triangles had specific patterns. And if we memorize that pattern, we could solve the questions with those triangles, assuming we only knew a single value. As long as we got one single value from that triangle, we could solve for all the other missing sides because we know that pattern. So our 45, 45, 90 pattern is that the two legs of your triangle, the shortest sides of those triangles, those will always be equal. It's essentially an isosceles triangle because it has two 45-degree angles. So in our pattern, we write those as x because those are that's the number that's going to keep reappearing throughout our triangle. So x might be 7, x might be 3, x might be 4, but whatever, those two sides are going to be always the same length. Now, our hypotenuse on our 45, 45, 90 triangle was always that same value of x times radical 2. So if x was 7, it'd be 7, 7, 7 radical 2. If x was 3, it'd be 3, 3, 3 radical 2. 5, 5, 5 radical 2. It could be anything, 100, 100, 100 radical 2. But it will always be that pattern. So as soon as you know whatever that value of x is, you could solve for all of the missing sides on the special right triangle without having to do any math at all, just because we know that pattern. Our 30, 60, 90 triangle was similar. We have our 30 degrees, our 60 degrees, and our 90 degrees. Now, it's important to know which degree is which because that's going to determine where these values fall. So the shortest side opposite of the 30 degrees is x. That's going to be the number that's going to keep reappearing throughout our triangle. The hypotenuse opposite of our 90 degrees is 2x, so it's always double the value of your shortest side. And then across from our 60 degrees is our longer leg of our triangle, our 60-degree leg, which is x radical 3. So once again, x could be any number. It's just a number that keeps reappearing. So like 7, 2 times 7 is 14. And then this would be 7 radical 3. Or 8, 16, 8 radical 3. 2, 4, 2 radical 3. It's always your length, double your length, and then your length times radical 3. That's your 30, 60, 90 pattern. So let's look at a few questions for this. All right, so I have a 45, 45, 90 triangle here. I have two legs that are 6 degree or 6 length. So I know that my longest side, my hypotenuse, is always x times radical 2. So my length for this one is, if x is 6, it's just going to be 6 radical 2. Let me copy this so I can place that easy. All right, 6 radical 2. Pretty easy. Let's look at this triangle over here. So I have 25 radical 2 as my longest side. Well, I know it's always x radical 2. So x has to be 25 in this case is the number in front of my radical 2. So that means this side over here needs to be 25. This side over here needs to be 25. All right, so pretty easy. All we have to do is look for that x and we can fill in the missing pieces. Same with our 30, 60, 90 triangles. So 30, 60, 90, across from my 30 degrees is my x, across from my 60 degrees is my x radical 3, and across from my 90 degrees is my 2x. So across from 30 degrees is 15. So that means 15 is my x that's going to keep reappearing. So that means my hypotenuse is always 2x. So 2 times 15 is 30. And my longer 60-degree leg is always x times radical 3. So that would be 15 times radical 3. So this would be 15 radical 3. Now, again, this second one, they gave me my hypotenuse. So thinking about my pattern, my hypotenuse is always my longest side, which is the 2x. So if I take half of this, I will get half my shorter side length. So half of 10 is 5. So that's going to be my side that's across from the 30 degrees. And then 5 radical 3 is going to be my 60 degrees because 5 is my x. So 5 radical. Last one. On this one down here, they gave us 17 radical 3. So 17 radical 3 is across from my 6 degrees. So the number in front of my radical 3 is my x. So 17 is going to be my x. So that needs to go on my 30-degree side, which is my shorter side. And I need to double it then for my hypotenuse. So double 17 is 34. And that is my 30, 60, 90 triangle. So once again, assuming you know your pattern and assuming you know one piece of that triangle, you can solve for any 30, 60, 90 or 45, 45, 90 triangle with that information. Now, sometimes we run into situations where we have these radicals in the denominator. And we looked at this a little bit on Thursday or Friday, depending on which day you saw this. And we had to do what was called rationalizing the denominator. Because we had talked about how having a radical in the denominator is pretty much bad notation. It's like having a sentence without capitalization or no punctuation. It's just bad writing. And so with mathematicians, we don't like having these radicals in the denominator, so we need to simplify them. So what we talked about on Thursday, Friday was that we needed to multiply the numerator and denominator by that denominator in order to cancel out that radical. Because I know radical 2 times radical 2 cancels out and leaves me with just normal 2. But in order to cancel out my numerator and denominator, I need to multiply, or I needed to multiply both my numerator and denominator by radical 2. That way, nothing changes and my equation is still the same. Because if I look, radical 2 divided by radical 2 is still just essentially 1. So I'm multiplying by 1. So my fraction is not saying my fraction is not changing at all. I'm just rewriting it to make it look nicer. So I know when I multiply by fractions, I multiply top and bottom. So 20 times radical 2 is 20 radical 2, because they're not like terms. One's a radical, one's not. And then radical 2 times radical 2, we talked about with our exponent rules. A radical is essentially having an exponent of 1/2. So this is 2 to the 1/2 times 2 to the 1/2. I can add those 1/2s together to get 2 to the 1, which is just normal 2. So we can also think about squaring is the inverse of radicals. So this is essentially radical 2 squared. So my radical and my square would cancel out. And then 20 radical 2 over 2, I can simplify this. 2 and 20 can divide. So 20 divided by 2 is really just 10. So this is really just 10 radical 2 or 10 radical 2 over 1, but I don't need to have that 1 there. And that is our simplified version. So we noticed a pattern on Thursday or Friday. We said all we had to do was look at that numerator, divide it by the number inside the denominator. So 20 divided by 2 is 10, and then add on that radical afterwards, and that would be your solution. So for this one, all I have to do is divide 16 by 2, which is 8, and then add on my radical at the end, which is just radical 2. And that would be simplified. I don't have to go through all the steps. I can just use this quick pattern. 10 divided by 2 is 5. Add on radical 2. 12 divided by 3 is 4. Add on radical 3. So it works with any radical. And we could go back and do the math and check, but all these are going to stay the same. They're all going to come out the same answer. 15 divided by 3 is 5. Add on radical 3. And then 24 divided by radical 3. 24 divided by 3 is 8 radical 3. And that's all we need to do to simplify. Well, why are we talking about this? Why is this important? Well, sometimes in special right triangles, they give us the side that isn't the one we want. So they give us a side that typically has a radical in it, but they don't give us a radical. So you're probably thinking, okay, this is my hypotenuse, so this should be 14 radical 2, but they didn't put the radical 2 down. So now I need to think, okay, wait, what's going on if I don't have this 14 radical 2? Well, I know this side is supposed to be equal to x radical 2. So in order to solve for x, in order to figure out what my x sides are, my legs, I need to figure out what is the x in front of this radical 2. Well, in order to get this x, I would need to divide by radical 2 to get rid of my radical 2, to get rid of my coefficient. So radical 2 divided by radical 2 cancels out. But then this gives me 14 radical 2. So x would then be equal to 14 radical 2. Well, what is 14 radical 2? Luckily, we just figured out this pattern. All I have to do is divide 14 by 2, which is 7, and then multiply by radical 2. So x equals 7 radical 2. So that means my two sides are 7 radical 2 and 7 radical 2. And I'm done. We can do this also with our 30, 60, 90 triangle. So they gave me my 60-degree side, which I know is x radical 3. So 30 degrees, or sorry, not 30, just 30 in length equals x radical 3. Well, if I want to solve for my x, which I know is my 30-degree side, I need to divide by radical 3 to get x all by itself. So I'm going to divide by radical 3. Divide by radical 3. Well, 30 divided by radical 3 turns into 10 radical 3. That's equal to x. So that means my shortest side of my triangle is going to be 10 radical 3. Well, what's my 2x side going to be? What's the double that length? Well, I just need to double my coefficient in front of my radical 3. So that's going to be 20 radical 3, assuming I just multiplied this by 2. 2 times 10 is 20. And those will be my three sides. I have 10 radical 3, 20 radical 3, and 30. So it looks a little bit backwards because typically we don't like having that longer leg being the side that doesn't have the radical 3 in it. But if that's the only information they give us, then sometimes we have to divide by radical 3. So it gets a little bit trickier, but nothing we can't accomplish. So this is your special right triangles review. Let me know if you have any questions over this. Have a great day, whether it's virtual or in person.